about acid-base reactions. So acid-base reactions are also called neutralization reactions. And this is because the acid and base are going to neutralize each other's properties. So they're going to kind of cancel each other out, is what this means. So that's when an acid and a base react, it's a neutralization reaction because they kind of cancel each other out. So here's an example of an acid-base neutralization reaction. All right. So if you see here, it starts with an H. It's got NO3. This is going to be an oxyacid. So here's my acid. And here you've got the OH, so you can think of the Arrhenius definition. Here's an OH. This is my base. So an acid and a base is going to react together in my neutralization reaction. Okay? Now, in a neutralization reaction, you're always going to end up getting the same things. Okay? So the first thing we're always going to have is we're always going to have the exact same net ionic equation. So you're going to have the same net ionic equation for an acid-base reaction. So acid-base reactions have the same net ionic equation, which is always H plus AQ plus OH minus AQ goes to water as a liquid. And you can actually practice this. So this is my molecular equation. You could break it down, all the aqueous items, break it down into the complete ionic equation, cancel the spectator ions, and write your net ionic equation, which would be this guy. Okay? So you can actually figure that out yourself and check that. Another thing that we have with every acid-base reaction is that we're always going to have acid-base, and when they react, they're always going to form a salt and water every single time. So every time I have an acid-base reaction, you're always going to get a salt, not salt like NaCl salt, but a salt. But you remember a salt is just an aqueous ionic compound. So a salt is just an aqueous ionic metal and polyatomic cation, anion, an aqueous ionic compound, and water. So that's what you get every time you do an acid-base reaction. So let me actually look at an example. Whoops. So here we can look at this. This is my acid-base reaction. So I have HCl, that's my acid, hydrochloric acid. With NaOH, it's got the OH, that's my base, sodium hydroxide. In this case, it actually forms salt and a water. Okay? So my two clear liquids, they're going to react. My acid here, my base here, they react to give me my salt and water floating around. So clear, clear, clear. There's no precipitate forming. And here, the reason it's no reaction is because I get a liquid forming. If both of these were aqueous, then you would say it would be no reaction. But water is going to be in the liquid state, and so this is why it's no reaction. It's actually something you have to write out. Now, in these, we can actually write out the different parts. So I said you could check yourself and write out the acid-base reactions. You could break it apart. So we actually want to practice this. So it says write the molecular, ionic, and net ionic equation for the reaction of aqueous nitric acid with aqueous calcium hydroxide. So first we want to write out the molecular. So to write out the molecular is just like we did when we were writing out balanced equations. And we had to take the names and figure it out. So what's happening? I've got nitric acid, which is aqueous, reacting with calcium hydroxide. hydroxide, which is aqueous, and I'm gonna have to figure out what it's gonna make. All right, so nitric acid, so it's got acid in the name, so I know it's H+. There's no prefix, so I know this is a oxyacid, and so I know that this is gonna be a polyatomic. It ends in ic, which means my polyatomic ion is gonna end in 8, so nitrate. Nitrate is NO3 minus. I cross down and I get HNO3. Just practicing my names of my acids to my formulas. Then we have calcium hydroxide. Calcium is Ca. Calcium's in group 2, so it's going to have a +2 charge. Then I have my hydroxide. It ends in IDE, but this isn't an element. So I gotta figure out, that must be a polyatomic ion. What is hydroxide? It's OH minus. Cross down, and I get CaOH2. Can't reduce that. And I know it's aqueous from the description of the problem. All right, now I wanna figure out what are the ions I'm gonna make. So to figure out the products, I've got H+, NO3 minus, Ca +2, OH minus. The H+ wants to go with another anion. He already went with him. He doesn't want to go with a cation because two positives don't want to be together, so he's going to go with him. And then NO3 wants to go with the other cation. So H+ is going to go with the OH minus. Ca +2 is going to go with the NO3 minus. Right? This is just water. Okay, so this is just water. This I cross down, and I get CaNO3 2. Okay, I got to figure out what the solubility is of this. I know this is water, and I know it's a liquid. Because I also know this is an acid plus a base. So I know acids plus base always forms a salt and water. So I need to check on that salt. So it was Ca +2N. So Ca +2, NO3 minus. So I look, do I see a Ca +2? Nope. NO3? Yep. Any exceptions? Nope. So if NO3 is here, it's soluble. So this doesn't tell me anything, but this tells me that this guy is soluble. So if he's soluble, what do we write? AQ. So now I have all of my guys. Okay? So HNO3 aqueous plus CaNO3 2 goes to my water. Nope, I forgot AQ, which is a liquid, and CaNO3 2 AQ. Balance it. I got HNO CaNO, HO CaNO. Get one H. I get one N from here, but then I have two N's from there, so I get 3 N's total. Oh, I copied that down wrong. Whoops. I was wondering, that doesn't make any sense. Try that again. This is CaOH2 aqueous. All right, try that again. HNO and Ca. All right, H I get from here and here, so I get 1 from the first one, 2 from the second, so that's 3. N is only there. O I get 3 from here and 2 for here, so that's 5. And 1 Ca. H is just here. N is here, which is 2. O is 1 from here and 6 from there, so I get 7. And 1 Ca. So I don't want to do CHNO, so not CHNO. So then I want to say, okay, CAs are good, N's are not good. Do I want to balance it on that side or this side? So I'm going to do this side. And so what do I need to put right here to get 2 N's? I put a 2. So now what that means is this first number, instead of it being 1, now this is 2, which means now I have 4. Now I have 2 N's. Now this number, instead of it being a 3, is now a 6, 2, which gives me 8. Okay? So CAs are good, N's are good. So now I can do H's or O's. So it doesn't really matter. So we can do the H's because this is in 1, 2, 3 places, where the O's are in 1, 2, 3, 4. So let's do the H's. So I have 4 on this side, I have 2 on that side. So I gotta put a number on that side. So what do I put in front of the water? I'm gonna put a 2. So that gives me 4. Now instead of 1 here, that gives me 2 and 8. So now I am balanced. So now I have my molecular equation. All right, so now that I have my molecular equation, now I can write my complete ionic, or my ionic. So I take everything that is aqueous and separate it. And it helps, since I already separated it here, I already know what all the ions are. So when you write the molecular, it kind of helps you. So this is going to be H plus, but I know when there's 2, so 2H plus AQ. This is going to be my NO3, but there's 2, so 2 NO3s. I'm going to have 1 Ca, and he's a plus 2. I have 2 OHs, OH minus, AQ, because remember, you have them all here. So you don't have to really rethink about what the charges are. Water's a liquid, so water stays by himself. I have Ca, I have 1 Ca, and a plus 2, and I want to write it on this side so it's real obvious. And I have 2 NO3 minus AQs. All right, so now I have the complete ionic. Now I need to do the net ionic, but to do the net ionic, I need to know who my spectator ions. So who's the same on both sides? He and he are the same, him and him. So my spectator ions are NO3 minus and Ca plus 2. So if I take out my spectator ions, I get my net ionic equation, which is 2H plus AQ plus 2OH minus AQ goes to 2H2O liquid. And remember I said if you can reduce these, to go ahead and reduce them, so we'll reduce them to 1s. So I can just erase them. And I get H plus AQ goes to OH minus AQ to water, liquid, which we said was what I should always get with my net ionic equation. So if I get to the end and I don't get this, then I know I messed up somewhere in the beginning. So that's my molecular equation, my complete ionic equation, and my spectator ions, and my net ionic equation. And that's where we're going to stop for this chapter, and we'll finish the rest up next semester.